All right, so this is part 2 of 6.3, which is piecewise functions. So yesterday we talked about how to get the range and stuff like that from a piecewise function on a graph and how to evaluate a piecewise function. Today we're going to talk about graphing them. So there's actually like kind of 2 approaches to graphing. You can basically graph full complete graphs for every part of the individual function and then erase what doesn't apply, or you can plot some points from within the ranges and just graph those. So I'll show you how to do both, and then you pick whichever way you want to do it. It'll say something just like this: graph this function, and obviously when you look at this you should notice it's a piecewise function. So it's saying that g of x is equal to 1/4 x plus 3 for the values of x that are less than 0, and it equals negative 2x plus 3 for the values of x that are greater than or equal to 0. So I'm going to show you the first method, which is graphing and erasing, and then I'll show you the plotting of the points so you can kind of figure out which way you want to do it. So the first way to do it is literally just graph 2 full complete graphs. So the first one will be y equals 1/4 x plus 3. What kind of graph is this? It's a line. Good. So I'm going to start at 3, go up 1 and over 4, and I can reverse it, go down 1 over 4 so that I can get a straight line, as straight as I can get it. Exactly. So now this is only true for the values of x that are less than 0. So now we're talking about the horizontal axis, right, because that's x. Where would x be 0? Right along the y-axis, right? So I'm saying that this is only true for the values that are left of that. So they are true from this point and left. And the fact that it's not an or equals to tells me that's an open dot. So now I would erase everything to the right of it, because those values would be greater than 0. So this point here, like if I wanted to graph it, this would be an open dot right on 3. And then the other equation, so let's graph this in a different color, would be y equals negative 2x plus 3. Again, it's a line. I start at 3 again, and I go down 2 into the right 1. But this is only true for the values that are now greater than or equal to 0. So this is a solid dot. Everything to the right of my axis would stay, and everything to the left would get erased. And the reason why this is a solid green dot is because this says or equal to. So if it's or equal to, it's solid for whichever one that is. So the other method to solving this, so I'm going to kind of erase this. And this might come in a little bit more handy when you're dealing with parabolas, because these can involve parabolas and cubic functions and all that sort of stuff, is I can take the values from the range that they're giving you and plug it into a t-chart. So if I wanted values that are less than 0, I would start at 0 and just make sure that's an open dot, and then go less than 0, like negative 2 and negative 1. So I could have just taken those values and plugged them in, okay? And so I would have done 1/4 times 0 plus 3, which would be 0 plus 3, which is 3. And then 1/4 times negative 1 plus 3, negative 1/4 plus 3, which is 2 3/4. And then the last one, 1/4 times negative 2 plus 3, which is negative 1/2 plus 3, or 2 1/2. And then I would have just plotted these points. So I would know that this one's the open dot, 0, 3 is the open dot, but it is the first dot. -1 and 2 3/4, and -2 and 2.5, and then I know that my line would be pointing this way. And then do the same thing for the other one. Start with 0, and then I want the values that are greater than it. So plug in 0, 1, and 2. Plugging in 0 would give me 3, plugging in 1 would give me 1, and 2 would give me -1. So then 0, 3, which is now solid, because it's or equal to, 1, 1, and 2, -1. And so my graph goes like that. So you could choose which way you want to use. Like I said, probably with lines, the first one's not so bad. When it starts to get into parabolas and stuff, you might want to start including the points so that you have exact values. No, I don't care which way you choose. Stick with whichever one makes the most sense to you. Isabel. So I need 0 because I'm not going to plug in 0.00001 or -0.001. I use 0 as the first guide, but that would have been an open dot on the blue. It's just that it overlapped with the red that it became solid. So you still want to include that point. You just want to make sure that when you graph it, it's open. All right, now we've got one that's broken down into 3 parts. Okay, x squared minus 3 if it's less than 0, 1/2 x minus 3 if it's in between 0 and 4, and x minus 4 squared minus 1 if it's greater than or equal to 4. So you can see that there's a blend of different types of graphs. What is x squared minus 3? What kind of graph is that? It's a parabola. So again, you can use either option. I could kind of just plot this as it would have been in a race where it doesn't need to go. So x squared minus 3 is a parabola that's transformed in which way? Down 3. So that graph, so if I did this one in red, I'll do this one in red, would have started down 3 and then something similar to this. Now without plotting points, I don't have exact points. This is an approximation. And it's only true for the values that are less than 0, which means I would erase everything to the right of the axis and give that an open dot because it's less than 0 and not less than or equal to. With me so far? Okay, second one is y equals 1/2 x minus 3. What kind of graph is that? A line. I would start at -3 and I would go up 1 and over 2. And this or equal to tells me this is going to be a solid dot, so I might as well make it solid dot. Up 1 over 2. And it would go in that direction. The first one, the red one, was an open dot. So again, we have an overlap which makes it go back to an open dot, to a solid dot, but I'll show you in a second what would happen if it wasn't. So now this is only true for the values from 0 to 4, which means I'm going to erase four and over. And it should be an open dot on 4, where x is 4. And then the last part, y equals x minus 4 squared minus 1. What kind of shape is that? Parabola. And the minus 4 inside the parentheses does what? Right 4, and the minus 1, down 1. So I go to the right 4, down 1, and it would be a parabola that looks like this. Good. The left half. So I want it to be greater than 4. Ian.
I don't understand the part where, like, since the red and the green lines they share one point, like, how do you know if it's open or closing in?
So as soon as one closes it is in, it's closed.
They can't go back to open?
It won't go back to open. But I'll show you an example where they wouldn't overlap so you can kind of see what that would look like. Any questions so far? So the other option here would have taken the points from 0 to -1, -2 maybe, plug them into the first function to see what that curve does. Then take the points from 0 to positive 4, plugged it into the green function to see what those points were. And then taken the points from 4 to positive, so maybe like 4, 5, 6, and plug them into the blue function to see what those points are. So those would be getting exact points, but you only have them within the range. Correct, yeah. I would probably do 0, -1, and -2 for that first one, just making sure that first dot is on the 0 would be open. So the way that you can see this, like if it wasn't overlapping, so let's say this was the same exact function, but let's say this said x squared minus 3, let's say this said 1/2 x plus 3, and let's say this said x minus 4 squared minus 1. Okay, let's say that the sign in the middle has changed. That's the only thing that we did different. Isabel. I would have plugged in 0 and 4, at least those two, and then maybe 1 in between. Because I want to know where it is when it's supposed to end. But again, that would be an open dot. So why don't I walk through that process after I do this? I'll walk through how to plug in the exact points. Okay, so let's say we start the exact same way. Let's say that these are all true for this, the way that they were. So this is the first one. It would have been down 3. It would have been just the left side. It would have been an open dot because it's not or equal to. Does that make sense so far? And then let's say that this is my second one, where I would have started at plus 3, gone up 1 over 2. So that line would have looked, like this initially, and I would have erased everything left of the 0 and right of the 4. The on the 0 would be a solid dot because it's or equal to there, but the 4 would have been an open dot. And then the last one would have been right 4, down 1, solid dot. So it would have been a parabola like this, and I would have erased everything left of the 4. So now you can see kind of like the stop and start points of the solid points and the open points. Does that make sense? So where it was where it's not or equal to, that would have been an open dot. This would have been an open dot. And then where it is or equal to would have been the solid points. You with me? Questions? Okay, so let's plug in some values. So let's say I was graphing using the T-chart, and I'm going to use the initial one, okay? So for that one, I would have started at 0, because I need to figure out what's happening at 0, even though that's going to be an open dot. And then I would have done -1, and I would have done -2. So if I plug those in, 0 squared minus 3 is -3. -1 squared is 1 minus 3 is -2. -2 squared is 4. 4 minus 3 is 1. So I've got 0, -3, which would be an open dot. I've got -1, -2, and I've got -2, 1. So my parabola would be like that. And this is obviously a little bit more exact because I actually have points instead of an estimation. For the second one, I would start with 0, maybe do 1 or 2. It doesn't matter what you do in between, but definitely go to 4 because I want to see what happens at 4. So I'll do 2 just to make it a little bit easier. Plug in 0, 1/2 times 0 is 0, minus 3 is -3. Plug in 2, 1/2 times 2 is 1, minus 3 is -2. And 4, 1/2 times 4 is 2, minus 3 is -1. So now these points went 0, -3. This time it's a solid dot because it's or equal to. 2, -2, 4, -1. Oh wait, I did that one. And that one's an open dot. And then for the last one, I would start at 4, and then maybe do 5 and 6. So 4 minus 4 squared minus 1 is 0 minus 1, which is -1. 5 minus 4 squared minus 1 is 1 squared, which is 1 minus 1, which is 0. And then 6 minus 4 squared, 2 squared, which is 4, minus 1 is 3. So I've got 4, -1, and this time it's a or equal to, so it gets a solid dot. 5, 0, 6, 3. And there's the other half of my parabola.
So that third part, the bottom of the blue one, that one's solid?
Right, because of this or equal to. So everywhere the or equal to is, that graph at that point should be solid.
Like at what point does like the approximation part of the parabola right and the part like one?
I mean, it's just not as exact. That's all. It's just not as exact.
Okay.
So obviously the points are going to give you a more exact graph, but as long as you're within reason and you get that shape, I'm okay with it.
Okay.
Other questions? So again, choose between them you want, but sometimes it's easier to do one or the other. Okay, and then this one, a little bit easier because this time there's no points to plug in, right? There are two parts to this function, but what's true about a y equals 4 and a y equals 2? What kind of lines are those? If there's no x, what kind of line is it? What kind of line would be y equals 4? It's a horizontal line, right? So I don't have to plug in points. You with me? This is like going back to that first kind of example, right? This is where a stepwise function comes into play because these are constants. So for the values of x being less than or equal to -1, I want my y to be 4. So from here, let me do it in the colors match. From here, left of -1, I want it to be at 4. And then for the values from -1 and bigger, I want it to be at -2. But that time it's not an or equal to, so it gets the open dot. Questions on any of the graphing? Okay, so I'll overlap this with your evaluating. If I said to evaluate where x equals 3, what do you do from that? That's what we did yesterday, right? The 3 tells me which part of the function to pick, right? So what would be the answer to, what is that, an f? F of 3. Is 3 less than or equal to -1, or is it greater than? It's greater than -1, which means the answer should be -2. Does that make sense? Yeah? What if I said x is equal to -5? What would you tell me? X is 4. What if I said x is equal to -1? X is 4. So you want to pick the one that's the or equal to, not the greater than or less than. Okay. Questions overall? All right, so you can use the remaining time